When I was a kid, I would lay up in bed looking at this very same lava lamp, and I pretend that there was a battle waging between the two sides, the bottom and the top, sending off projectiles and armies toward each other. And now it's also been interesting to consider, what if it could make music? And of course, the lava lamp doesn't have any perceptible sound, but using some basic electronics, I'm actually able to give us what you're hearing right now, and it correlates to the movement of the wax. So I had two approaches to do this. One was by measuring capacitance. So the idea would be to put two plates here and then have varying dielectric constants in between the wax and the mineral oil. It would change, but that didn't work. The dielectric constant was too small and the capacitances were too small. And so actually what I used was a photoresistor, and I'll bring you over and show you that in a second. But in this video, I want to show you how to replicate this setup and just show you some of the interesting features or tricks I found along the way. And then maybe at the end I'll just let it play for a couple minutes just so you can hear it. So let me actually remove the music, and I'm going to go over to this camera here, and we're going to go manual mode. So now you're getting a different angle at the system, and it's not anything super special really. I've got a ring stand here, but you could use a block of wood or make something more elegant, which I very well may do in the future. But there's a photoresistor right here, and that's what's taking the measurement. This photoresistor changes resistance with different light values. So that's coming into an analog input on my Arduino. And so my Arduino is responsible for measuring that resistance as it changes, or the voltage across the resistor. And then I've got some coding on here that allows it to generate MIDI signals. And so that's actually the more persnickety part, or actually setting up the computer is the most persnickety part. So actually I'm going to move over to the computer and show you the software setup to get this to work. And also, like I said, some interesting tricks that I'd found along the way. So first, here's the code that we have. It's not a really big code, and what's most interesting is it was all generated with ChatGPT. I really wanted to see if ChatGPT could get me where I needed to go, and it turned out that something this simple, it actually did a pretty good job. At the very start, I had asked it to recommend softwares that I could use, because I wasn't really familiar with MIDI, anything to do with MIDI, to be entirely honest. And it gave me some ideas. I didn't end up using any of them except for this one, Dext, right here, which I'll get into in a second. But then I had to start generating the code. And so this one was some code to make row, row, row your boat, just to make sure my circuit was actually working and outputting. And for a while it wasn't. But then eventually after going back and forth and having it modify and give it code, I was able to tell it what sort of scale I wanted. So you can see, well, actually I can show you the code. To tell it what scale I'd wanted, right? And so you can actually see, I eventually wanted options to have multiple scales: major, minor, pentatonic, blues, and harmonic minor. So these are MIDI values that are associated with the notes on this scale. And all this code is really doing is it's reading in on analog 0 a voltage, figuring out which note it needs to play. So first it figures out which index on this array, and then from this array it will return what note to actually play, or what note value. Right, so there's where we actually select it. And then there's just some really, really basic logic to make sure that every time a new note happens, if it's the same note, we actually don't want it to go dun, 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 dun. I want it to sustain. And so this is just some basic logic to sustain a note. And then I have some delay in here just for some stabilization. And so this is something that I'll link below for code if it's something that you're interested in. But I also need to show you the rest of the setup. So one of the critical parts is actually this thing right here, Hairless. So Hairless is a software that allows my MIDI signal, or rather my serial signal from Arduino, to come in and generate something that appears like a MIDI device to my computer. And so Hairless MIDI is a free and I believe open source software that takes care of that. And then I'm using this software called Dext. So Dext allows me to, if I go to my MIDI settings, this loop MIDI port right here, that's also the loop MIDI port right there. And so this is allowing me to take in the MIDI signals, right? And so all it is information about what notes I want it to play and what sounds I want it to play. And this is actually synthesizing the sound. So if we head back over to, we turn our sound back on, you can see right now it's playing a C4. And we'll see when it sends another signal. Right now it is sustaining, and now you saw it's going through a couple signals right now. Let me see, actually I might be able to get the picture-in-picture of the lamp, is it? So this is like a real synth simulator. There's a couple tones that work pretty cool with this actually. This encounter tone that's built in. Let me see if I can find it. So we'll see when that bulb on the bottom kind of pops together. So that one was an interesting one. This other one, this P-Ice, is sort of interesting. It really fits the color scheme of the lava lamp. It has kind of a interesting decay on it. So this is the software that was really necessary, right? I needed the Arduino, and I used ChatGPT to write it. And then this is necessary to make the Arduino seem like a MIDI generating device. And this is what I use to generate the tones. And so I think at this point I could really use, this software is called Dext, but I could really use any software that handles MIDI and to generate tones. I just kind of liked some of the sounds that I got here and that it was free and open source. So these are all things that I'll link below. So I think what I'm going to do is I'm actually going to go back to camera 3 and I'm going to change it over to, let's go to one different tone here. Sahara is the tone I'm going to go to, and I'll turn it back on. Now I gotta wait for something to happen here. That is one of the things, is, as you can see, right, it does kind of stabilize at some points. So you want to be careful what tones you use in terms of the way they sustain, if they sustain and drone for a long time. Seems alien, which is kind of what a lava lamp seems like visually. Almost majestic. turn it down here. So this is actually a project that can be done pretty inexpensively. I mean, all I'm really using is an Arduino and a photoresistor, and that's roughly $3 or $4. But I would say the result is actually quite beautiful, and it's something that could really easily be integrated into something that sits on the wall or sits on a shelf and makes these tones. I'm maybe considering making an art display for myself. So anyways, I'm gonna link all of these things below so you can try and replicate this yourself. And if you like this video, let me know what other things you might like to see me do. So thanks for watching.